now, yeah. Okay, so real quick, those on Zoom, did anybody have any questions that you want to make sure I answer before we get going? If you do, I want to write it down. Is only Brooklyn left?
It looks like it.
Okay. Okay, so Brooklyn, are you able to stay? Oh, okay, no worries. Okay, that's fine then. If you're able to stay, I'm not gonna rush you. Okay, so number 19.
It says 3.625.
Okay, so I'm gonna do 3.7 first, all right? And then I'll do 3.6. So 3.7, oh, thank you for telling me. Okay. Vertical asymptotes at x equals 5, x equals -5. Here, read me the problem for me. Anybody got it that they can read it to me? All right, it's gonna take me forever.
Number 19.
Number 19.
Write an equation for the rational function. So the vertical asymptotes at x equals 5 and x equals -5.
Okay.
X intercepts at 2, 0 and -1, 0. Y intercept at 0, 4.
Okay. And that's it? That's all the information?
Number 19.
Okay. So go ahead and yeah, so the vertical asymptotes, these are going to be the denominators. Okay, that's going to form the denominators. So if x can't be 5 or -5, then in our denominator, that's going to translate into x minus 5, x plus 5. I'm writing them in factored form. See that? Okay, so that's the vertical asymptotes. The intercepts, the x-intercepts, that's going to give us our numerator. So if our intercepts are x equals 2 and x equals -1, what would that look like in the numerator?
X equals positive 1, x equals 2.
Which as a factor, I'll write as x plus 1, x minus 2. Perfect, thank you. You see that? Okay. Now the last thing is there could be something here in the front. There could be an a value. Remember that? And it's possible it's a fraction, and if it is, that's fine, okay? But it's possible we have something in front, and we're going to figure out if we do based on the y-intercept. So this is going to give us a. It's going to tell us what a will come out to be. So I'm going to plug in 0 for x, and then for f of x, I'm going to write the 4, okay? So I'll have 4 equals a times 0 plus 1, 0 minus 2, over 0 minus 5, and 0 plus 5. So what do I get next to a? Yeah. And then that's all over what?
0?
Not quite. Because they're multiplied.
Oh, -25.
There you go. Right? Because -5 times +5 is just -25. Are we okay with that? Okay. So then if I want to solve for a, what do I do?
Times by 25?
Yeah.
Or -25?
Yeah.
-100?
I'm going to write -2a instead of 2 times -a. Or, I'm sorry, instead of a times -2. I'm just going to put the -2 in red. So then to solve for a, we do what?
-2? Not a -2?
Yep. So a is 50. Positive 50. Okay, so there's our final function then. F of x equals 50 times x plus 1 times x minus 2 all over x plus 5 and x minus 5. I think that's it. I think that's all I wanted. Okay, so Brooklyn, you had the question 3.6, number 25. Are there any other questions in 3.7?
It's a double zero.
Huh?
What does it mean by double zero at x equals 2? It says on number 23, it says vertical asymptote at x. The same problem as this, but it has it listed as one of the characteristics as a double zero at x equals 2. Does that mean again?
Oh, meaning it's a multiplicity of 2?
Oh, okay.
I think that's what that means. So it's going to be squared on that factor.
Okay.
Yeah. Did you want to do it?
No, I just wanted to know.
Okay, yeah.
I would like to do that one.
You want to do that one? Okay, we'll do that one real quick. Okay, sorry, 23? Is that what you said?
Yes.
Okay. So read me all the information.
Vertical asymptote at x equals -1, double zero at x equals 2, y-intercept at 0, 2.
Sorry, x equals -2 is the double zero, and what was the last one?
Oh, x equals 2, not negative.
Okay,
And then the y-intercept is at 0, 2.
0, 2. Okay, do I have that all written correctly?
Yeah.
Okay, so there's our denominator. So what do we have in the denominator? Yep, change it into factored form, so x plus 1. Okay, now this means multiplicity of 2, and it's my numerator. So what's going to go in the numerator? Yes, x minus 2, that's the factored form, squared. Perfect. And then we potentially have a in front, and we'll find what a is using the y-intercept. So we'll plug in 0 for x, 2 for f of x. 2 equals a times 0 minus 2 squared over 0 plus 1. Now we're just going to solve for a. So what do we got?
4a over 1.
Yeah. Since it's over 1, I'm not going to bother. Okay? So if I wanted to solve for a, I should just... Exactly. So that'll reduce to a half. Okay, so a came out to a fraction this time. So when I write it, my final answer, it's a 1 in the numerator and a 2 in the denominator. You don't have to write the 1 in the numerator, but there's certainly nothing wrong with writing it. It's perfectly fine. And there it is. Oh, good. I'm so happy. All right. So 3.6 then, we'll backtrack. And you said number 25, Brooklyn?
Yeah.
so they just want us to find the zeros and write in factored form. Okay, all right. Can somebody read me the function?
I think it's x squared minus 4x plus 13.
Plus 13, you said?
Yeah.
Okay. Can we verify that?
I don't know.
Okay, and that's f of x, right? We called it f of x?
I didn't write it out.
We didn't write it? Okay.
I wrote f of x.
Okay, okay,
Then
cool.
I wrote it.
Usually it is. Okay, fabulous. Okay, so, we could try factoring, but I can already tell you that's not gonna work with 13, right? Okay. So, probably gonna need to use the quadratic formula. All right, what's the quadratic formula?
Minus b plus or minus square root of squared minus 4ac over 2a.
Perfect, good job. Well done. Okay, so in our equation, b is -4, c is 13, a is 1, right? Okay, cool. So let's plug it in. So x equals what?
4
Uh-huh,
plus or minus square root of negative 4 squared
good,
minus 4 and 13
good.
all over.
Well done. Okay, so get our calculators, and let's figure out what's under the radical. You got -36? You did too? Okay, great. That sounds great then. Sounds like we have a -36 under the radical. And then it's all over 2, right? 2 times 1. So, just so we know where that came from, that's going to be 16, right? And then what's 4 times 13? 52?
13.
So 16 minus 52 should come out to -36. We did that correctly. Here, I'm gonna put it in just to make sure. It does. We're amazing. Okay, fabulous. So now, because it's negative, we do what?
Limit, like, if one.
Yeah. So the negative we represent with I. Remember that? I mean, we didn't really talk about it. You watched the video on it, and I was like, I. All right, great. So here we go. This becomes I instead. And now we'll take the square root of 36, which is 6. All over 2. Okay. So are we clear where 6i came from? Okay. Now I'm going to break it up and reduce. Okay, so that's going to reduce to what? 2 plus or minus 3i. So there's our zeros. We've solved it. There's the zeros. And then to write it in factored form, you'll write x minus 2 plus 3i times x plus 2 minus 3i. Oh wait, minus. Double minus. There we go. Are you going to let me draw the effing minus, you a-hole? You mock me with your slowness. I hate you. And I love you. But mainly hate you. Yeah. All right, there we go. I'm very mean to inanimate objects. I'm just very cruel. They're very indifferent to me, so it's fine. All right. So that'd be how you write it in factored form. Which is kind of silly, if I can just be honest. I don't really, you've noticed, I very rarely ask you to do that. Did you notice that? That's because it's, who cares? Like, why write it in factored form? I don't quite understand what the purpose is for them. I mean, I know what it could be if we're trying to finish solving it, but I don't find it very important. So, just a note, make a note of in your head. Okay, technically class time is over, so if you do have to leave, it's okay, I understand. But do I have any more questions? Because I'll keep going until I have to stop. Not from you. What about you, Brooklyn? How about anybody else? None? No?
We're coming back on Thursday to lab with questions, but all right.
Great, no, that's great. That's the goal, okay? You know that now. We're all prepared for what we're gonna see for the rest of the term.
Yeah, when's the point, well, the chapter 3.
It'll be due on a week from today, because that's when you'll turn in the midterm. I like your thumbs ups, guys. They make me happy. Okay, all right, so Brooklyn, are you good? Do you have any additional questions? Otherwise, you guys are free to go. Thank you. Okay, thanks, Tilly. Oh, Tilly, I didn't see you there. Oh, and Andrea, what the hell? They didn't show up. Holy cow, I didn't realize all of you were still there. That's so funny. You guys didn't see them either, right?
No.
Okay, all right.